All right, so we're going to wrap up similar figures today, coming back and talking about what we've done in the last couple lessons, and again, how that's going to let us solve problems. So here's the lesson objectives, the definition of similar figures, how to determine if they are similar, and how to use similarity and proportion to find measurements of similar figures. So there's a little review here. Solving proportions using cross multiplication. So we have x over 3 equals 4 over 9. What are the steps for solving this problem? So this is where the stylus, you could try to see if it'll let you write on the screen. Again, if you have a touch screen, you can use your finger. But once you've written your answer, you need to go ahead and submit it, because all the answers will get submitted to me. All right, I pulled up one of the answers there because it said list the steps. It did not say solve this for me. It asked how would I solve this. So this one says I'm going to cross multiply and then I'm going to reduce, which is the steps that we would take. Not that the math is wrong that was submitted to me, but it didn't ask for you to solve. It asked for the steps on how to solve. So now on this screen, they're giving you the solution. They're showing you two methods. And really the method on the right is just knowing you're going to end up dividing by the 9. So it's kind of skipping a step there. So if you were to solve, you cross multiply. So you have 9 times x equals 4 times 3. And then divide the 12 by the 9 and then reduce. So cross multiply and reduce. Could you have left this as a decimal? Absolutely. But if you're going to leave your answers in fraction form, you have to make sure you reduce. All right, here's a little activity that I'm going to let you do. It says, imagine we have an array that shrinks geometric figures. Sketch a triangle that shows the original shrunk to half its size. Okay, I'm going to share with you a couple different drawings to see what different people did. So here's one drawing, and we'll talk about these in a minute. So there's one way that someone drew this. Here's another way that another student chose to complete this. So now, when you sketched your triangle, how did you go about it? So you have to look at the shape, because we've discussed it's still got to keep the same type of shape. It's got to be smaller. How do the sides of your triangle compare? If we were shrinking it, what should you be able to say about the sides of your triangle? Smaller by what? Half. There should be a relation. Remember, we were shrinking it in half. And how do the angles of your triangle compare to the original? Yeah, the angles should still be the same, because we discovered that even if they're similar, the angles are still congruent. So here's the definition of similarity. Two figures are similar if the corresponding angles are congruent and the corresponding sides are proportional. So they've listed out all the angles are congruent. For all the sides to be proportional, that means that they all reduce down to the same ratio. And then they're giving you the statement there, ABCD is similar to QRST, and they tell you that symbol is used to say that the figures are similar. All right, you have a little quiz question there to answer. All right, here's the correct answer, of which 66.7, so 2/3 of you got correct. Two figures are similar if what has to be congruent? The angles. And what is proportional? The sides. That would be the correct answer. Angles are congruent, sides are proportional. So now we've got two figures here, and we want to know, are they similar? To determine if two figures are similar, angles must be congruent and the corresponding sides must be proportional. So they've got all the angles marked that they're congruent, so the first criteria has been met. And then they match up the corresponding sides. And if you notice, all of those reduce down to the same fraction. They all reduce down to 2/3. Because the angles are given as congruent and the corresponding sides all form equal ratios, we can conclude that EFGH is similar to MNOP. Scale factor. Really, those ratios that were found on the previous page, that was the scale factor. That tells you what is used to grow or shrink one figure to the next. So that 2/3 is the scale factor that is happening. All right, now you have two questions there. You may need a calculator for this, so you may need to get out a calculator. You might need scratch paper to determine if these two different sets of figures are similar and to put your answers down. I will pause while you do that. Okay, so let's go through a couple answers here. So the first one here, sides are not proportional on the left, similar on the right, scale factor of 2. Next one, no, the scale factors are different. Yes, the scale factor is 1/2. No differences in each triangle. Yes, by 0.5 or 1/2. No, they're not. Yes, scale factor of 2. No, because they don't match. 2. A no and a yes. I think we had trouble on the reducing there. The 2/4 would become 1/2. But why am I getting some people telling me on the right that it's 1/2 and some people telling me that it's 2? What is happening to get me those two different answers? I'm getting agreement on the left. You're telling me, no, those are not similar. They're not proportional. And everyone's telling me yes on the right. Why am I getting the two different answers? Why are some people telling me it's 1/2 and some people telling me that it's 2? Aaron? So it depends on which way you're talking about. If you're going from the big one as the first one to the second one, then yes, it would be 1/2. You're taking 1/2 of the first one to make the second one. If you start with the little one and are going to the big one, you have to multiply it by 2. So it depends on which way you're talking about scaling it. And they did not give you any directions here on which way to scale. So it's either one of those could be the answer that we were looking for. And so here they tell you 3/4 does not equal 4/5, does not equal 5/6. But on the other side, 2/4 equals 4/8 equals 1/2. Now they went with the 1/2 because they went left to right. But again, those of you that said 2, you are not wrong because it did not say to go from what figure to what figure. So both of those are correct. I'm going to play, I tried playing this on all devices in first period and that didn't work, so I'm going to play I don't know if you guys get to see this video now. That might be... Okay, something important that he's pointing out right now, just like with congruence, we said order mattered. We matched up the order in which the letters. The same thing applies to similarity. A, B, C, D is similar to A, K, H, G is the same thing. A matches up with A, B matches up with K, C matches up with H, D would match up with G. Those would be the angles that would have to be congruent to each other, and we use those parts to match up to solve.
Naming of the similarity, we are clued into which parts are corresponding. So angle A has to be congruent to itself, angles B and the angle here at K would have to be congruent, and so on. So the way we name the similarity tells us which parts are corresponding. So first off then, our task is to find the value of x. So I look here and I find where x is on the smaller figure, and I'm going to set up a proportion. So x would correspond to this side on the larger figure, so x would be to 10, and so now I need to look for another pair of sides between the two figures where I know both the values, and that appears to be here with 6 and 8. Those two sides are corresponding, and we know the length of each one. So x over 10 has to be equal to 6 over 8, and then we can use the process that we learned earlier on in the warm-up to cross multiply and solve. So I'll multiply the 10 over this way. So x is going to be 60 divided by 8. And as we reduce that down, I can do 30 over 4. That's 15 over 2, or 7.5. So x equals 7.5. And then similarly for y, we got to set this one up. This problem's a little more challenging, because y in the figure represents just a portion of one side. So we have to think about how we're going to work the y in. So y is part of the longest side on the larger quadrilateral. So that long side of that quadrilateral is actually going to be y plus 9. And then that's going to compare to just this long side here on the smaller quadrilateral, which is 9. So that's a ratio of the bottom edge of the bigger figure to the bottom edge of the smaller one. Again, I'll go back to the 6 and 8 as my known pairing, but this time I set up my proportion as larger to smaller. So I will do the same here, putting the 8 over the 6. As we multiply this, I'm going to go ahead and cross multiply in this case. So I'm going to take the 6 and I'm going to multiply that over here to the y plus 9, and then I'm going to take the 9 times 8. So I have 6 times y plus 9, and then the 9 times 8 is going to give me 72. Here I have to distribute in to the parentheses, so 6y plus 54 equals 72. 6y then is going to equal, when I subtract out the 54, I get 18, and so then when I divide by 6, y is going to have to equal 3. So we're using proportions to set up and solve, we're using the known sides and we're setting up and solving proportions involving our variable so that we can find the missing values.
Okay, so that a couple things that are very important here that he talked about. You have to know one pair of sides. You have to know what one ratio is going to be. You can't have two unknowns to go ahead and solve this. So each time he used the same. Now you notice he used 6 over 8 here, but he switched it to 8 over 6 because the first time he went from the smaller figure to the bigger figure, so he had to stay consistent and go smaller to bigger. The next time he reversed it, started with the big side, so then he had to reverse his ratio to match up. You have to be consistent going from one figure to the other in setting these up. So that is important as we're going on. All right, you have a little quiz there to do. Which proportion would allow you to find the value of x given that triangle ABC is similar to triangle JKL? So I'm sharing with you the results and how you did. The correct answer was D, and again, it comes down to matching up the correct parts. You have to match up from one triangle to the next. Sorry. So that you can, if you look at the diagram, pull it up again, so that you can see the reason D is the correct answer. X matches up with 7. So since I went from the bottom triangle to the top triangle in the first ratio, I have to do the same thing and go from bottom to top in the second ratio. So the summary here, two figures are similar if the corresponding angles are congruent and the corresponding sides are in the same proportion. If the figures are similar, then the common ratio formed by the corresponding sides is the scale factor. If two figures are similar, we can use proportions to find lengths of unknown sides. And you have a quiz to take right now. Okay, I know everybody is not done at this point, but because of time, I'm going to go ahead and share out what has been answered so you can see how you did and look at what you answered and what the correct answer should have been. And then you have one last question to answer. Before you can leave, you need to quickly answer this last question.